Angle similarity theorem. Now, one of the things that you have to remember with this is only with triangles. If two angles of one triangle are congruent to two angles of another triangle, then the two angles will be similar. Now, these are our symbols for congruent and similar. Make sure you remember these symbols. We will use them. They're also a way for you to shorthand your notes, is to use the symbols. Now, to determine if triangles are similar is what we're doing in this first problem. If they're similar, then you have to write a similarity statement. Now, with this one, you have to look at the things that are alike. If you notice, angle U has the two congruent marks, and angle K has the two congruent marks. So that means that angle K is also 65 degrees, just like angle U. That means that we look at what we have in triangle UVT, and we can calculate the third angle. And in this one, you're going to use the triangle angle sum theorem. So let's make note of that. Use the triangle angle sum theorem. And we're doing this to show congruent angles. Now, if we have our triangle, which is 180 degrees, and we're going to subtract what we know, 65 degrees plus 55 degrees, that should give us the measure of angle T. 65 plus 55 is 120. 180 subtract 120 equals the measure of angle T. So that gives us 60 degrees equals the measure of angle T. So we have 60 degrees, which you will notice matches up with angle J. So because of this information, we can say that triangle TUV is similar to triangle JKL by use of the angle-angle theorem. So it proves that these two triangles are similar, and this is our similarity statement. Now, let's look at B. Angle B, we know that these two angles are congruent with each other because these two are vertical angles. We learned that several units back. Because of that, we have one pair of congruent angles. However, we cannot prove that angle B is congruent to anything, angle T is congruent to anything, or angle U is congruent to anything. This pair, we have to say, no, they're not similar. And the reason they're not is they only have one pair of congruent angles. Now let's look at our next example. We are asked to show that these two triangles in letter A are congruent. So let's look at a little bit of information that we know. We know that angle GIF, which is this angle, is 90 degrees. So we can state that the measure of angle GIF equals 90 degrees. Now, the reason that we know that is because they are supplementary angles. Right here, we have a pair of supplementary angles. This angle is labeled as 90 degrees. So we know that angle GIF is congruent to angle HIG, and because they're both equal to 90 degrees. So we know they're congruent to each other. That gives us one of our angle pairs right there between two triangles. Now, we can also say that the measure of angle FGI is 51 degrees. So the reason that we can say that is this angle is 90 degrees. This angle is 39 degrees. 90 plus 39 is going to give us a total of 129. 180 subtract 129 will give us 51 degrees. So that means this one is 51 degrees, which is FGI. So we can also look, and the reason we know that is the triangle sum theorem. We now look at angle G, and we can see that 51 plus the measure of IGH right here, so 51 degrees, plus the measure of angle IGH is going to equal 90 degrees. We are told that that whole angle is 90 degrees. So we subtract 51 from 90, and that tells us that the measure of angle IGA equals 39 degrees. And the reason is those are complementary angles. If you notice right here, when we list all of our reasons, we're creating a proof. Don't let that go unnoticed. So we now have two triangles, one shaped like this. So we have G, I, and F. And we have a second triangle that's shaped like this, G, I, H. We have 39 degrees here, and we also have 39 degrees here. That gives us 90 degrees here and 90 degrees here. So because of those being congruent, we can say angle IGA is congruent to angle F because they're both 39 degrees. So that gives us our second angle. So we have two congruent angles there. So because of that, we can say that triangle GIF is similar to triangle HIG. And the reason is the angle-angle similarity theorem. Now pause the video and go look at the second problem on this page on your own and determine if these two triangles are similar. Now, the first thing that we can do is we look at the things we know based on information that we are given. The first thing we can look at is that triangle CEA, which is right here, and angle DEB right here, these two are congruent angles. We know this because they are vertical angles. So let's go ahead and state that. Angle CEA is congruent to angle DEB because they're vertical angles. Now, this gives us one of our angles. So we'll put an A and circle it. We can also look at this and we can see, we notice our two lines are parallel. That being said, line AB here is a transversal, which means angle B and angle A are congruent to each other. Angle B is congruent to angle A, and the reason that they are congruent is they are alternate interior angles. So this gives us another angle that is congruent between this pair. So we can now say that triangle CEA is similar to triangle DEB by the angle-angle theorem. In our next problem, a tree casts a shadow that is 60 feet long. So let's draw a picture about this. So we have our tree, that is an unknown height. We have our tree that makes a 60-foot shadow. At the same time, a 6'2" man is staffing nearby, and he casts a shadow that is 48 inches long. So we have a man that is 6'2", and he is casting a shadow that is 48 inches. Now, here's the problem. We can't just say that we're going to set this up with 6'2" and 48 inches. We need the same measurements all the way through. So the very first thing we're going to do is let's take this off. And we're going to take this off because we want to change everything to the same unit. 48 inches, yes, we can change that to feet. 6'2" is going to give us part of a foot. So let's look at inches because all of these numbers can be changed to inches. So we have 48 inches, 60 feet long. We would multiply 60 by 12, and that would give us 720 inches. And 6'2", we multiply 6 by 12, that will give us 72, plus 2 is 74 inches. So now we have all of this information that is in inches. So we have our height of our man. We make these into triangles. And now we can re-put our information. And we can say that the tree is X. We're going to leave that there. The shadow is 720 inches. The man is 6'2", 74 inches, and it casts a shadow that is 48 inches. Now we can set this up as a proportion. We can say that X corresponds with 74, and 720 corresponds with 48. Now we can cross multiply. So we multiply 48 times X and we get 48X. And that will be equal to 74 times 720, which will give us 53,280. Now we're going to next divide both sides by 48. And that's going to tell us that X is equal to 1,110 inches. But we don't want to know how many inches. We want to know to the nearest foot how tall is the tree. So we now can divide our inches by 12, and that will give us the number of feet. When we do that, we will get 92.5 feet. So our tree is 92.5 feet tall.